Good day, everyone. Good day, sir. My name is Jean Gamil Urakoy from Group 3 of Session 1, and together with my group mates, we will be tackling about the strength of acids and bases. So, at the end of this lesson, we will be able to illustrate the similarity and differences between a strong weak acid and strong weak bases. Also, we can be able to predict the direction of reaction and lastly, construct an equation for acid-base reactions. But before that, how do we differentiate an acids from bases? Both acids and bases are polar opposite. Why polar opposite? Since acid is a proton donor and base is a proton acceptor. In other terms, acids share their protons. Tapos si base, siya ang mo receive sa proton gihatag ni acid. Which is why they have a relationship na polar opposite. Other than that, their respective pH level also differs, since an acid has a pH level below 7, while the base has a pH level above 7. So, a great example of acids are sulfuric acids, which are present in the production of fertilizers, explosives, dyes and pigments, and other things. Example of bases is a calcium carbonate. It is a dietary supplement that is used when calcium taken in a diet is not enough. Also, it is used as an antacid to relieve heartburns, indigestions, and upset stomach. Now, let's proceed to the analysis. The question is, what do you think is the importance of knowing the strength of acids and bases? So it is very important or very essential because acids and bases react so easily and they play important roles in chemical reactions. Moreover, all acids and bases do not ionize or dissociate to the same extent. So this leads to the statement that acids and bases are not all of equal strength in producing hydrogen protons and hydroxide ions in a solution. Dissociation is the process by which the acid or a base separates into ions in water. So this is the general process in which molecules separate or split into other things, which is called atoms and ions. This is usually in a reversible manner. So the strength of the base is determined by the moles of hydroxide ions, in which are produced for each mole of the base that is dissolved. So when a base or an acid separates or ionizes, the process is called dissociation. Strong acids and bases dissociates completely or thoroughly in water, while weak acids and bases will only undergo slight dissociation or slight ionization in waters. That is their big difference. Now let's proceed to the next topic, which will be discussed by Mr. Edmar Kumaling.
Good day everyone, I am Edmar Ikumaling and I am gonna talk to you about what is the difference between strong and weak acids. Well, firstly, strong acids is an acid that completely dissolutes in an aqueous solution, while weak acids is quite the opposite of that. These are the type of acid that does not dissolute completely in an aqueous solution. Firstly, we're gonna differentiate on how these acids are strong and weak acid dissolute in water. So firstly, the dissolution of strong acids leads to a transfer of an hydrogen ion to the water. Take a look at the example given in our presentation. The HCl plus H2O is to H3O plus Cl minus hydrogen chloride plus water plus chlorine is to hydronium plus chlorine. Ang hydrochlorine i-mix nyo siya sa water. So after mix mo sa water na ionization ang kitabo, so nag-transfer ang isa ka hydrogen ion to the water, thus making it transfer. So as you can see, after the equation, the water became H3O plus. So meaning na nag-transfer og ion si chlorine, so hydrochlorine nag-transfer siya og ion to the water, thus making it H3O. And now let's talk about the diprotic acid. This is the type of acid that has two hydrogen ions and which dissociates separately. Here in the presentation we have example, which is H2CO3 plus H2O is equal to H3O plus H2O3. So what's this? The HCl3, the carbonic acid plus water is equal to hydronium plus bicarbonate ion. Meaning this is firstly ang carbonic acid, which is H2CO3, is example for diprotic acid, which means duha iyang hydrogen ion sa siya. So after sa ionization, after siya mag-dissolve to water, mo siyang resolution circle. So moving on to the next slide, we see here another example, which is just a continuation. So file ko siya itong first equation. So as said earlier, ang diprotic acid duha iyang hydrogen ion. So tapos separately separately dissolute. Yun na, kaduha siya nag-dissolute. So looking at another example is the HCl3 plus H2O is equal to H3O plus CO3, 2 minus. So we're gonna put this in a words term. So bicarbonate ion plus water is equals to hydronium plus carbonate ion. Firstly, ang bicarbonate ion and water mo siya ang byproduct atong last dissolution. Sa HCl3 mo siya ang product atong last dissolution as equivalent. So as stated kanina, kaduha or weak acid, this is a type of weak acid, so kaduha siya nag-dissolve. So HCl3 ma-dissolve siya sa water again, so tanggal ihang hydrogen ion, so mag-give na siya hydrogen ion. Meaning ang H plus is 2O is because mahimo siya hydronium H3O, and then wala man iyang another hydrogen ion, so nahimo siya CO3, 2 minus karon siya nakuan, so meaning carbonate ion. To put it in simple terms, the carbonic acid loses one hydrogen ion to form bicarbonate acid, and this bicarbonate acid loses another hydrogen ion to form carbonic acid. So that's all for my explanation and presentation. Moving on to the next supporter.
Good morning, everyone. So let's proceed to the difference between strong base and weak base. So what is the difference between the strong and weak bases? Similar to the strong acids, the strong bases also dissociate completely in water. Dahil ang strong acid is completely ionized in an aqueous solution, so same as the strong bases that completely dissociates in water. Since strong bases are ionic compounds, so when they are dissociated, it will give an aqueous solution that contains metal ions and hydroxide ions. Strong base also is a compound that has an ability to remove a proton from a very weak acid, and a base also ionizes in water and produces large amount of hydroxide ions. So next is, they can be very soluble in water and few are less soluble in water. As the strong and weak bases act exactly the same way as the strong and weak acids, because the strong base is fully dissociates, or it dissociates 100% of the time, while the weak base is not fully dissociate, and it is favor on having or staying as a molecule, but do have some dissociation, which belongs to group 1A. Hydroxide are considered to be very soluble in water. That gives high concentration of OH minus ions. An example of that is hydroxide or sodium hydroxide. So the last one is, weak bases are poor acceptors of hydrogen ions and they produce very few ions in the solution. Weak base also is a basic substance that do not completely ionize in water, so that the resulting aqueous solution contains only a small proportion of hydroxide ions. In addition, A strong base is completely dissociates into ions when dissolved in aqueous solution, while a weak base is partially dissociates into ions when dissolved in aqueous solution.
Hello, my name is Marjorie Lumocho and I am assigned to report about the direction of the reaction. So in every chemical reaction, there are always present of 2 acids and 2 bases. For us to determine the direction of this chemical reaction, we should determine first which are the stronger acids and bases and the weaker acids and bases. So in the chemical reaction example attached in our PPT, we can see that sulfuric acid dissociates with water and its products are hydronium acid and hydrogen sulfate ion. So we can say that sulfuric acid or H2SO4 is a strong acid which readily gives up H plus to the water. For we already know that acids is the one who is capable to donates H positive to the base, and the base are the one capable to accept H positive from the acid. So we can see that sulfuric acid is a strong acid because as we can see it in the products, the sulfuric acid now becomes hydrogen sulfate ion, or it loses 1 mole of H positive, and the stronger base is the water, because as we can see it in the product, the water now becomes hydronium acid or H3O positive. So now that we have already determined which are the stronger and the weaker acids and bases, we can now determine the direction of the chemical reaction. So now let us first define what is chemical equilibrium. So chemical equilibrium is a state in which the rate of the forward reaction equals the rate of the backward reaction. In other words, there is no net change in concentrations of reactants and products. So and in order to reach equilibrium in the chemical reaction, the base and the acids which are stronger will react in the direction of the acids and base which are weaker. So as in the example of chemical reaction, it is mostly products, and we can say that a chemical reaction is called product favored if there are more products than reactants after the reaction is completed. So that's all. Thank you.
In order for us to understand the topic, we have provided an activity for you, a Venn diagram of the similarities and differences of the strength of acids and bases. The difference between strong acids and bases from weak acids and bases is that strong acids and bases completely ionize or dissociate in an aqueous solution, while weak acids and bases only dissociates partially and not 100% complete. While the similarities between the two is that they both undergoes dissociation. That's all. Thank you.